on it when we are now dealing with finding the equation. For now, I just want us to have a look on possible questions that can be asked when the graph is given sketched already. Because now we are dealing with sketching the graph. But what if you were given a graph that is already sketched for you? So let's assume that we are having something like this. This is a graph that is given, already sketched. Then this is our turning point, y-intercept, let's say -4. Then our TP is negative. So x is positive, maybe it's a 3 or a 2. Let's make it a 2. Because the distance from here to there must be the same from here to there. So from here it's going to be 3 units, so it's supposed to be a 2. Then let's say we are going to have our y as a -8. So this is what we are having now. So in this situation, possible questions that can be asked is the domain, range, axis of symmetry, shifting, reflection. So these are possible questions that you must expect from a given graph. They can ask you these questions. You must be able to answer all of them with confidence. It's very, very important. And if you understand me very well here with parabola, you'll be able to apply the same questions on the hyperbola graph. So it's very, very important for you to listen very, very attentively. The concept is the same, just that with hyperbola you'll be now having a different shape of the graph, but same concept. Domain, remember we once dealt with domain when we're dealing with a straight line graph. We said it's a set of x values where the graph is found. It's our domain. So you check where the graph exists as far as x is concerned, meaning if it's the x values, you need to check it horizontal. Do you find your graph this side on the positive x values? Yes, the graph is there. Does it exist everywhere? Yes. Does it have any restriction? No, which means it exists everywhere because it's opening in this way. While it's going up, it's moving to the far right up until infinity. So it does exist. Do you have your graph this side? Yes. Does it exist this side? Yes. Does it have any restriction? No. It will move to the left forever. So the domain of parabola will always be the same, unless if you are dealing with an inverse of a parabola. So the domain of a parabola, the fact that it exists everywhere to the left and to the right in all x values, our answer is going to be x element of real numbers. That will be your answer. It means it exists everywhere. You can just write it in this format another way, from negative infinity to positive infinity. Don't forget, you have to use round brackets. So that is another way of writing x element of real numbers. So let us now move to range. Range, these are set of x or y values, a set of y values where the graph exists or is found. So because you are dealing with the range and these are y values, you need to check how the graph behaves going up and going down. Do you find your graph up? Yes. And does it move up forever? Yes. Arrows are telling you that the graph will move up forever to infinity. Do you have your graph down? Yes, it does exist, but does it exist forever going down? No, it only exists starting from here. moving up. So how do you write your answer? Your answer, it means your graph will only be found starting from this y value going up. But remember, don't use the x value because you're dealing with a range. These are y values. So in this situation, our answer will be y, element of real numbers, but your y must be greater than -8. But don't forget that we have an equal to here. An equal to, it means it starts exactly here on -8, not above 8. It starts from 8 moving forward. So in the situation, or moving upwards, so you have to include an equal to here on -8, meaning your graph starts exactly from -8 moving forward or upwards. So this is your answer for the range. Let us go to the axis of symmetry. Axis of symmetry, it's a line that cuts the graph into two equal parts. So remember, we dealt with domain, we dealt with range, so they will ask you to find the equation of axis of symmetry. So to find the equation of axis of symmetry, you must first identify where do you find the line of axis of symmetry. The line of axis of symmetry, you're gonna find it here. It cuts on the x value of the turning point, meaning that's where the graph is cut symmetrically, meaning it's divided into two equal parts. It's meaning it's cut asunder. So it means the axis of symmetry will lie here. So, but do you realize that axis of symmetry is a line that is cutting the x-axis? So the fact that it's a line that is cutting the x-axis, which means our equation must be in the form of x. So our equation for the axis of symmetry, axis of symmetry, which is the equation. So our answer is gonna be x is equals to a 2. It cuts on the x value of the turning point. So sometimes they can ask you the axis of symmetry on the graph, or maybe they already give you, maybe they say a 2x squared plus a 6, maybe minus 8. Then they say find the axis of symmetry in this situation. The graph is not sketched for you yet. So what you do, remember, I said the axis of symmetry will cut the x value of the turning point, meaning find the x value of the turning point using this -b all over 2a, substitute. Then your answer will be that axis of symmetry. That will be that equation. So it's very, very important for you to understand that. So check something. While we are dealing with the axis of symmetry, you realize that this line axis of symmetry is the midpoint of these two x-intercepts, or is the center part of these two x-intercepts, meaning the distance from here to there is the same from here to here. So our x value here is a 2. From here to there is 3 units, and from here to this part it's also gonna be 3 units. So in other words, if I was not given, let's assume here it was a -1 here, here it was a 4, here I'm not given this x value. Using that method of axis of symmetry, you're supposed to be able to get this value, because I know that from here to here it's 1 unit, from here to here it's 4, meaning altogether it's 5 units. From here to here it's supposed to be 5 units also. So from 4, if you add 5, it will give you 9. So you need to understand that concept. So yeah, we are having a 2 here. Here we were having a 5. Yes. So that will be your equation of axis of symmetry. Let us now move to the shifting of the graph. So in terms of the shifting of the graph, let's assume the equation, because remember I had to form this or sketch this graph on my own from my head. So let's assume that the equation of this graph is given by f of x is equals to x squared, let's say, plus let's say a 2x minus a 4. Let's just assume this was the equation, just assumption. Then they ask you that find a new equation when this graph is shifted. The question says, remember we are now dealing with the shifting. We are done with axis of symmetry. Now we're dealing with the shifting. The question says find the equation or find the new equation when the graph is shifted, let's say 1 unit to the right. That is the question, meaning find the new equation if the graph is shifted 1 unit to the right. So now in the shifting, understand it, you will apply it in all types of graphs or functions. So the shifting, the fact that it shifted horizontally, it means x values are affected, because shifting to the right or to the left, it affects the x values. Then you check that the fact that it shifted to the right, what sign do you find on the right? Do you see it? You find positive, positive, positive. So you do the opposite. The opposite of positive is negative. You write the opposite sign. Then you write the value that it shifted with. It shifted how many units? 1 unit. So you're gonna take what you just formulated, you take and substitute it wherever there is x. Why do you substitute where there is x? Is because shifting was to the right, and to the right, x values are affected. So in this situation, take this one, substitute it where there is x, then you simplify. That will be your new equation. Can we do that quickly? If we substitute wherever there is x, we substitute x minus 1 squared plus a 2, x minus 1 minus a 4. If you use your maths correctly, you're gonna get your final equation will be x squared. This and this will cancel. This and this will give you a negative 5, if I'm not mistaken. This will be your new equation. So yeah, so never mind. Remember this equation, I just formed it from my head. Now it's not the equation of this graph. I was doing it for the sake of answering the shifting question. Yeah, so this will be the new equation after the graph is shifted. But I can see if it shifted properly, it was supposed to be here, but never mind. So this is how the shifting will work. So let's assume that they say it shifted 2 units to the right. Let's just check what will be our new equation, or how our new equation will be. Shifted to the left, not right, because we're dealing with the right now, we are now dealing with the left. So you're gonna write an x, because shifting to the left or right affects the x values. To the left, you get the negative sign, you do the opposite is positive. You take this one, substitute wherever there is x. If you substitute wherever there is x, what are you gonna have? X plus a 2 minus a 4. So you're gonna expand, if you use your mathematical skills correctly, plus a 4 plus a 2x plus a 4 minus a 4. Your final equation is gonna be this, and this will give you plus a 6x. This is an 8 minus, it will give you plus a 4. This will be your new equation if it is shifted 2 units to the left. So basically that's how shifting works. So same thing applies to the shifting upwards. Let's assume that they say the graph shifted 3 units up. They want the new equation. Shifted 3 units up. Shifting up or down affects the y values. So you're gonna write your y value, because y values are affected. Then what happens is that up you find positive. So you do the opposite. The opposite is gonna be minus, then the shifted value is a 3. So wherever there is y on your equation, you substitute this. You now substitute it where there is y. You no longer substitute it where there is x. So your equation was given by y is equals to an x squared plus a 2x minus a 4. Let's substitute where there is y. So your y will be negative 3x squared plus a 2x minus a 4. If you transpose, your y will end up becoming a minus 1. So never mind, this will be a new equation. Remember I said this equation doesn't represent this graph. I just used it as an example. Because under normal circumstance, if you shifted 3 units to the right, up, do you see with this value, the turning point is supposed to go to 3 units up, supposed to go to a negative 5. This one shifted 3 units up, is supposed to go to a negative 1. Yes, it will go to a negative 1, which is your y-intercept will now move to negative 1. So that's how shifting works. Same thing will apply to the shifting downwards. Shifted 2 units down, shifting down, it affects y values. What sign do you find here down? You find the negative, you do the opposite, it's gonna be a plus, a 2. Wherever there is y, you take this one and substitute where there is y, it's gonna be y plus a 2 equals to x squared plus a 2x minus a 4. You transpose, if you transpose x squared plus a 2x, it will get a negative 6. This will be your new equation. And it must make sense that if you shifted 2 units down, this y value or y-intercept must go to negative 6. From negative 4 to negative 6. This will be your new equation. So basically, this is how you do the shifting of the graph. So you must apply it in all graphs, even on the exponential. They ask you about the new equation when the graph is shifted. You apply the same concept. So let us move to the reflection of the graph. When the graph is reflected now, we want to know how your equation is gonna be. Now, if the graph is reflected. So reflection, you must understand it very, 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 very well. So reflecting a graph, it's flipping it in this way. If you flip it in this way, it has to face down. So that is a reflection. But if you flip it in this way, this part it has to go this side, then the side it has to go that side. Or flipping in this way or flipping it in this way is still the same. That is the same shape that you're gonna get. So let us check our equation. Let's assume our equation was given as y is equals to x squared. We're still gonna use the same example of the equation that I wrote here, plus a 2x minus a 4. This is your equation. So in this equation, let's assume that they told you that find a new equation if this graph is shifted, sorry, it's reflected across the first one, across the x-axis. So reflecting it across the x-axis, this one is our x-axis. So reflecting this graph across the x-axis is reflecting it in this way or this other way. The shape is gonna be the same. You can just sketch this graph, have your paper, you flip it up or you flip it down, then you trace. The shape is gonna be the same. That will be the new shape of the graph. But we are not looking for the graph, we are looking for the equation. So you must understand that flipping it in this way or in this way, it affects the x values or y values. So flipping it up and down, do you see how my hand is moving? It's moving up and down, and you know that up and down, these are y values. So that thing must help you to remember that y values are the ones that are going to be affected, meaning x values will remain the same. So If y values are affected, how are you gonna now have your new equation? Meaning, in your equation, you're gonna just place a negative wherever there is y, because y values are the ones that are affected. So if you place a y, a negative where there is y, plus a 2x minus a 4. If you divide both sides by a negative, remember y must be positive. So you're gonna end up getting a negative x squared minus a 2x plus a 4. So it means your graph is now flipped, it's now facing down. So it does make sense because your value of a is now negative. So that's how reflection affects the equation. So let us move to reflected across the y-axis. Don't forget to drink water. Water is life. Don't forget to subscribe to our YouTube channel. Like and share. If you've got a question, you can just leave a comment there at the bottom. We'll attend to your question. Anything related to what we are doing, you can just leave your comment, or any topic that you need help with that you want us to record, we will do it for you. We are on reflection, reflecting it across the y-axis now. Reflecting it across the y-axis is reflecting it in this way. So reflecting it in this way is still gonna be facing up, meaning our value of a must never change. It must still carry the same sign, meaning positive. So reflecting it in this way, do you see how my hand is moving? Left, right. So it has to affect the x value or y value. It has to affect what? Correct. It has to affect the x values. Why? Because x values are the ones that will be affected, moving my hand left and right. So in this situation, wherever there is x on the equation, I'll substitute a negative. So check something. Do you realize that this negative I placed inside brackets? Very, very important, because if you don't place it inside brackets, it will end up having your a being a negative, which is totally wrong. So this thing, it means it's repeating itself twice. Negative x times negative x, it will give you a positive x squared. This one, a negative 2x minus a 4. This will be a new equation of the graph. Yes. So that's how reflection works. This will be your new equation of the graph. You can just draw this graph, flip it in this way, or flip it the other way. The shape that you're gonna get will be the new shape. It's still gonna be facing up. The value of a must still carry the same sign. It must still be positive. So basically, this is how, or these are the questions that you must expect. Domain, range, axis of symmetry, shifting, and reflection. So you must expect it in a given graph. So we are now gonna move to applying this equation. In application of this equation, don't forget that this one, you are using it to find the equation of the graph. Because here, this equation, remember, gave it to you. So they can give you this graph drawn for you, and they don't give you this equation. Then they say, find the equation. Y is equals to a x minus p squared plus q. But find this equation of this graph. Or they can ask it in this format, plus bx plus c. But find this equation of this graph. So it's very, very important to know the steps. Mostly we're going to be using that one to arrive to finding the equation of this graph. All right, moving forward, now we are going to get into the part where we are moving from this equation y is equals to ax squared plus bx plus c. When an equation is given in this format, which is y is equals to x squared plus a 2x plus a 3. plus a 4x plus a 3. When it's given in this format, they want you to convert it to this format. So you do that by completing the square. To complete the square, I'll show you two methods. It's up to you which one is gonna be better for you. So how do you complete the square? What you're gonna do, you take, remember we wanna convert from this format to this format. So you take this equation which is given by y is equals to x squared plus a 4x plus a 3. So what we're gonna do, we're gonna have the coefficient of x. So halving the coefficient of x, then square it. So it's gonna be a 4 over a 2, meaning we're halving it, then we square, plus this 3. Then after that you subtract it. So if you subtract it, it's gonna be a 4 over a 2 squared. So it's like nothing happened because this thing and this thing is the same. From here, if you simplify this, you're gonna have a 4x. This one will give you 4 divided by 2 gives you a 2. 2 squared, it's a 4. This one plus a 3, this one is gonna be a minus 4. So from here, you will factorize this part. Factorizing this part, it means it's repeating itself twice. We're gonna have an x plus a 2 and x plus a 2. It's a plus a 3 minus a 4. So this thing is repeating itself twice. Repeating itself twice is the same as x plus a 2 squared, meaning it's repeating, two brackets are repeating themselves twice. This minus this, it will give you a negative 1. This is how you complete a square. So another method of doing it, you can do it in this way. You can, remember we were moving from this format, x squared plus a 4x plus a 3. Then we want to write it in this format, x minus p squared plus q. So just find the value of, remember the a for this equation is the same as this one. So the a are the same, which is a 1. So I won't write it because there is an invisible 1. Then find p and q. P and Q are representing the turning points. So to find the turning point of this graph or this equation, it's given by negative b all over 2a. Then substitute the value of b and a. The value of b, it's a 4. The value of a, it's a 1. So if you simplify this thing, you're gonna get this one is a negative 2. Then to get the corresponding y value of the turning point, take this, substitute it to the original equation. What I'm gonna have is a negative 2 squared plus a 4, negative 2 plus a 3. Negative 2 squared, this one will give you a 4. This and this will give you, I think it will give you a negative 8 plus a 3. 4 plus 3 will give you a 7. 7 minus 8, your y will end up becoming a negative 1. Meaning the turning point that we have is going to be a negative 2 and a negative 1. But you're going to substitute the turning point. Remember for the p, when you extract it from the equation, it will change the sign. When you take it back, it will change the sign. Now having a negative 2, it will end up becoming plus a 2 squared. This one, the y1, which is represented by a q, it will remain the same as a negative 1. So this and this are the same. So I'll give you another example where your a is negative. I will apply it in this way of completing the square, and I will also apply it in this method. So don't forget, if you're substituting for the turning point, the x value, when you substitute it, it will change the sign. If it was a negative, it will end up becoming positive, and the y value, it doesn't change. So let's go to another example where a is negative. Alright, now we're gonna move to y equals negative x squared plus 2x plus 3. We want to move from this format to this format. X minus p squared plus q. Do you see now we're dealing with the one that is got a negative? We must complete the square. In completing the square, we will first have to factor out a negative here on top. Factor out a negative, this one ends up being positive, this one ends up being a negative, then this one ends up being a negative. So you have completed the square. So remember, if you have completing the square, you need to have the coefficient, square it, then subtract it. So if we have the coefficient of x is this one, so we're gonna half it and add it. So halving it is dividing it by 2. This is the coefficient of x, we just divided by 2. Then square it minus a 3. Then subtract what you did here. It's going to be a negative 2 all over a 2 squared. So this is what we are having. To simplify this, we're going to have x squared minus a 2x. This and this will end up giving you a 1 minus 3 minus 1. So you're going to take this first part, factorize it. If you factorize it properly, you're going to get to x, it's minus 1, x minus 1. Then this and this will give you a negative 4. But you know that this has to affect what is inside. Before affecting, you know that this is repeating itself twice, so it's going to be x minus 1 squared. Then it's affected by this negative will affect, and it will also affect a 4. So this is what we're going to have. This is our new equation after completing the square. Let's go to the second way of doing it. Remember, our equation is this one, plus a 3. We want to move to this format, x minus p squared plus a q. So in order for you to do that, remember I said this method number 2, you could just get the turning points, substitute them here because the values of a are the same. So the a value, the negative 1, get the value of p and q and substitute them. So here we're going to substitute the value of b. B is a 2, a is a negative 1, your x, we're going to get it as a 1. Take 1, substitute it back. If you substitute it back, you're going to get a 1 squared plus a 2x plus a 3. So if you punch on a calculator, you're supposed to get it as a 4. So your turning point is going to be a 1 and a 4. That will be a turning point. So when you substitute here, your x value has to change the sign. It's positive, it will end up being a negative, then you square. But the one for y doesn't change the sign, it will still remain as a positive. So do you see that this is the same as this one? So this is how you convert from one format of the equation to another one. Because sometimes they can ask you to find the equation of the graph, which is the part that we're now going to move into, finding the equation of a graph. So you need this knowledge. It's very, very important because they can say, find the equation of the graph there. Then they specify for you that they want it in this format or in this one. So you need to know how you maneuver your way around that part. So let us move to the part of finding the equation of the graph. Let me quickly wipe my board. Don't forget to subscribe, click to the notification button. Whenever there is a new video, you will be alerted. Don't forget to comment if you have got a specific thing that you want us to deal with on functions. You can comment there below. We can help you with that part. So now we are moving to the part where you need to find the equation of a given graph. Equation of a given graph. So in this situation, we are having something like this. We are having here, this is the y, This one is the x. So let's just wipe our board properly there. Properly there. Let's assume here we are having our turning point 3 and 2. This is our turning point. Then let's assume here we are given a negative 16. So remember, in this situation you are given the turning point and an extra point. They want you to find the equation of this graph. So it depends. Some questions specify that they want it in this format. Or some of them they can say they want it in this format. That's why what I was explaining a few minutes ago was how you move from that one to that one. How do you go back? By expanding. So it's very, very important. So in that situation, you check. Remember, you can be given a turning point and an extra point, or you can be given the x-intercepts and an extra point. So now, because you're given a turning point, you need to know that your equation that you're gonna use to formulate, or the equation that you're gonna use to find the equation of the graph is this one. So the first thing, you need to substitute the values of the turning point P and Q because they are given. Can we substitute the values of the turning point? If your x is positive, if it comes here, it will be negative. Then your y, if it's positive, it will still remain as a positive. So it's gonna be plus a 2. Then the only unknown now is a, because for the equation to be complete, we must have y and x as unknown. So, but we are having a as unknown. That's why they have to give you an extra point so that you can substitute that extra point, then get the values of the value of a. So the extra point, it's meant to help you with finding the value of a. So don't cram it. The extra point can be anywhere. It can be this x-intercept, it can be there, it can be there, it can be there, it can be anywhere. So here you are given the y-intercept. We know that x is a 0, so you need to know that. So substitute these values. This one is going to be a negative 16. Your x is a 0 minus a 3 squared plus a 2. If you simplify that, this one still remains as a 16. This one is your a. Then here you are having negative 3 squared gives you a 9. So you're having a 9 plus a 2. If you transpose this one, it's going to be a negative 18 is equals to a 9a, because this one will multiply each other. Your a will end up becoming a negative 2. And it does make sense because your graph is concave down, is facing down. Take your a and come and substitute it back here. If you substitute your a back here, you're going to have a negative 2x minus a 3 squared plus a 2. That will be the equation of the graph. But if they say they want it, because we got it in this format, if they want it in this format, the top part, you just have to expand. If you expand this one, we're going to have, this one is repeating itself twice. It's going to be x squared minus 6x plus a 9 plus a 2. This negative 2 will affect what is inside. It's going to be negative 2x squared plus a 12x. This one minus 18 plus a 2. Then y is going to be equals to a negative 2x squared plus a 12x minus 16. And it does make sense because our y-intercept is 16. So it will depend on the question that they wanted in which format. If they did not specify, both formats are acceptable. You can just end there. You don't have to go further and expand. So remember, you were given turning point and an extra point. Because turning point was given, we know that equation, this one, P and Q represent the turning points. That's why we had to choose this equation. Remember, I gave you 3 equations at first for the parabola. We dealt with that one, first one. We dealt with this one. Then there is another third one that we haven't applied, which is the one that we're going to apply now. So let's just have a look on the next one. Another example, finding the equation. Remember the one that we just did now, you were given a turning point and an extra point. Now you are given having a -2, a 7, here let's assume it's 14. So in this situation, they want you to find the equation of this graph. You are given x-intercepts and an extra point. So the extra point is meant to help you with finding the value of A. So let's just have a look on how you're going to go about. So remember, at first I introduced this equation when we started x1, x minus x2. So this equation is the one that will be the most appropriate to use. Why? Because it will be able to accommodate the x-intercepts that are given to you. So let us substitute the x-intercept. You're going to substitute them here at the end, the x1 and x2. But when you substitute them into the equation, they change the sign. So here we're going to have a negative. If it was positive, it will come and become negative. When you substitute it, it will be plus. Then this one, it's a positive. It will end up becoming a negative. So our equation is incomplete. We still have to find the value of A. The value of A, you have to substitute an extra point, which is the y-intercept in the situation. So we know that y-intercept x is a 0. Let us substitute, it's a -14. Your A is going to be given by, we are looking for A, x is a 0, x is a 0. Here, going to have 14. This one gives you a 2, this one a 7, this by this will give you a -14. A, if you divide both sides, you're going to get your A as 1. So your equation is going to be given by, wherever there is A, you're going to put a 1. So we know that there will be an invisible 1, x plus a 2, x minus a 7. Then there is this one that we placed here, but you don't have to necessarily have to write it. So if you expand this one, we're going to have x squared, this and this, this and this. It will end up getting a -5x minus 14. And it does make sense. Remember, this one represents the y-intercept, which is a -14. So if they never specify that they want it in which format, you can just end here. So which is the first format, this one that we spoke about at first. So what if they said they want it in this format? It's the part that we're dealing with, the one of completing the square. So you can complete the square based on how I explained a few minutes ago. So basically this is how you find the equation of a parabola. So I believe you gained a lot. Thank you. May you be blessed.